you'll remember Ed presented at our last forum. He was just getting started working on a new router. It apparently went very well because he's now talking about integrating that very new router into another tool set. So I will turn it over to Ed.
Thank you very much. As Marshall said, I'm Ed Gernert from Frontier Design. We started Frontier Design 2.5 years ago. It was founded by John Cooper, and John's the brains behind Cooper and Chan technology, if you remember. 30 years ago, that started the shape-based architecture. We have a brand new patent pending, high capacity, high performance platform. It's extremely flexible since it's based on shapes, and we read and write open access databases. I'm not going to go too much into our router, what we do, since I presented that last April. But it's constraint aware shape-based platform. It supports standard cells, chip assembly, and any kind of mixed. We're blockage and congestion aware, and there's no complex router setup. The internal strategies are automatically determined. There's no hidden switches. It's very transparent and fully automatic. It's 100% user GUI driven. So basically the user would just push a button that says Autoroute, and it would autoroute the design. It's got a full debug environment. You can zoom, pan, stop, pause, measure, query, and inspect during the routing. And we also support multi-threading. So what's new from last April? We are currently enrolled in Siemens EDA connection program. And with that, we have direct access to Tanner's LEdit product, which is their custom AMS layout environment. And through LEdit, we have access to Calibre now for design rule checking to self-verify ourselves. We currently use OA in and out of LEdit. So we would read the OA layout and the constraints within the OA. We would auto route it and then write back an OA routed database into LEdit. Tanner is a mixed signal IC system layout tool. It does SDL, LVS, DRC simulation. It writes and reads OA databases, real-time markers, runs on Linux and Windows. And if you'd like more information, I would go visit the EDA swsiemens.com. And basically where we would plug in is to the physical layout and verification. So you would do your schematic, you would do your layout placement, and then all the interconnect routing would pass through Frontier and then back into LEdit for physical verification. I'm going to show you two small examples. The first example is a digital block. It has 101 connections, 245 pin-to-pin connections, and it's 4 metal layers. We would read the OA, we would read the layout. You basically hit one button inside of our tool. It says Autoroute. It's auto-routed in 15 seconds, and on the bottom left is our status report. It's a full rip up and reroute, retry router, and all the internal strategies are automatically figured out based upon the layout. So it took 15 seconds, pretty small test case. So I'm just going to show you metal 1, metal 2 layers, metal 3, and metal 4. At this point, we would save the router results in OA and then pass that back to LEdit. The next test case is a little bit larger. It's got 14,000 connections, almost 2,900 pin-to-pin connections, and it has 10 metal layers. Again, we would read the OA layout, we would read the OA constraints, and again, inside of Frontier, you hit one button, auto route. It's going to go through a full rip up and reroute strategy, and as you can see on the very bottom, it runs some clean passes to reduce vias and such, and it auto routed this small test case in 22 minutes. Just going to show you some of the layers: metal 1, metal 2, metal 3, metal 4, metal 5, metal 6, metal 7, metal 8. There's actually 10 metals that didn't need to go up to the higher level. There's very few metal on metal 7 and metal 8. Within our router, if there was an OA constraint of a use layer, for instance, use layer metal 1 through metal 6. The router would use that. And here there was nothing, no constraint defined, so the router was free to use anything it wants. Again, we would write the OA and send it back to EDA. So what's next for us? A tighter integration within EDA is planned. We're going to support more native OA constraints. That's an ongoing task. Support more advanced nodes and constraints and routing features. And we are actually actively hiring and growing Frontier. We are currently actively seeking potential customers or partners to help advance our technology. The more people we get to use our tool, the more constraints we see, the more features we can add into our tool. And that's where we stand today. Once again, I'd like to thank SI2 for allowing us to present and showcase our product. We have a website, www.frontierrouter.com, with more information on what the actual tool supports, what it does, what it looks like. There's some interactive demos in there where we route a 400,000 connection standard cell in a couple minutes. So it's pretty interesting stuff. And within that website, there's a contact us. So if you have any more questions or you want to help us, you can fill out the information and send it, and I'll get it in my email. Once again, thank you very much.
Questions for Ed?
So did you already start for advanced nodes? Because I mean, these rules get fairly complex, right? Not only design rules, like also DFM rules. So any work done yet so far?
We're working on that, and that's why we're seeking partners to help us. So we need more advanced test cases. It's an ongoing process. It'll never end with the DRC rules node. So the two designs I showed you are an older node.
Right.
So we are working towards more advanced nodes.
Right. And yeah, about DFM. So any plans of, I mean, sometimes I want double vias or more robust routing, right?
Yeah, if there's a constraint for double vias, we support that now.
Okay.
Yeah.
But I need to, if I, let's say I have these newer technology nodes, I mean, my DRM is about 1,000 or 2,000 pages long. So essentially, I need to define these constraints myself, or are you even thinking about something where there is an electronic DRM where you just can drive?
That's the biggest problem, is the constraints. You know, TSMC, you need to be into their little group to get a hold of the DRM.
Exactly.
Yeah, so that's the biggest problem for us, is getting new constraints and new rules. In order, the implementation for that it's not trivial, but it's not too bad because we're shape-based. We're looking at shapes.
Right.
So we're looking at the interaction of 2, 3, 4 shapes and such. But we do need help in that area. And that's, being a small company with 2 people right today, is our kind of a limitation. So we're looking for more people to help us. Siemens has been great. They've been giving us some test cases, and we've been using that to work on more advanced constraints. But we do need more. And again, it's a never-ending task. It'll never end.
What's the difference of this routing tool with the place and route tool? Is this for digital place and route only, or is it also handle analog?
No, we're mostly focused on analog. We do some analog features like shielding. We're working on differential pair. They'll be coming up shortly. Matched and min length, multiple widths, multiple spacings. So it's for the analog. This is an analog router.
How you drive the connection? You use a spice netlist, or how you build the connection?
We read OA. So based upon the interconnects in OA is how we build the connection. So the placement's done already.
Okay,
and then so we have all of the ins terms and terms and such, and that's how we build the connection.
I see. Thank you.
Yeah, hi, this is Vic. Initially, you mentioned in the opening that you are also looking at some of the chiplets or chip assembly. Is that
Yes.
in the roadmap, or is that you have?
No,
done
we
some
fully
work
support
already?
chip assembly designs. Within the router, we do some specialized global. So we have a built-in global assist router. So if you go to our website, there's some demos there that have block designs that the router just automatically goes around blocks. It understands blocks, it understands congestion. I don't have a live demo to show you here because we're using what I've gotten from Edit. But yes, we do have a lot of block type test cases or mixed blocks with standard cells in the middle. And that's available today.
Thanks.
Sure. Well, thank you very much.
All right. Thanks, Ed.